So hello and welcome to Steps to Maths, and today we're going to be looking at working with indices. So in order to look at this, we're going to be looking at an example question, and the example question that I have is 3 to the power of x minus 2 is equal to 81 over the square root of 3, and that whole thing is squared. And the question is, what is the value of x? So any of the time that we're working with indices, we're probably going to be looking at numbers like 3 or 4 or 2. And we have to know the various powers of 3, 4 and 2. Powers of 3. 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 cubed is 27. 3 to the power of 4 is equal to 81. So you can see immediately that we're working with the number 3 and we're looking at the number 81 as well, and we can see that they are related. Similarly with 4, we'll find 4 to the power of 1 is 4. 4 squared is 16. 4 to the power of 3 is equal to 64. This is one to watch because occasionally you will also see that 8 squared is equal to 64. So depending on whether you're working with a number 3, a number 4, or number 8, excuse me, the power that you use is going to depend. So you need to know the various powers. So 2, 4, 8, 16, 32. This is 2 to the power of 1, 2 squared, 2 cubed, 2 to the power of 4, and 2 to the power of 5. There are a few other things that you need to know. You need to know that whenever you see a square root, for example, the square root of 3, if I see the square root of 3, I don't use the square root. Instead, I replace it with a power of a half. So whenever you see a square root of something, replace it with a power of a half. Okay, so and when you're working with the numbers 3, what we want to do on the right hand side is we want to replace everything over here with a power of 3 and then use our rules to write it as a single power of 3. So let's write this out again. 3 to the power of x minus 2 is equal to 3 to the power of x minus 2 is equal to 81 over the square root of 3 squared. Okay, so on the left hand side we have it written as a power of 3. In order to solve an indice type question, we need to write everything as the power of the same base, as a power of 3. So let's look at 81. We know that 81 can be written as 3 to the power of 4. So everywhere we see an 81, we're going to replace it with 3 to the power of 4 in brackets. Remember, anytime we're doing a substitution, for example, if we had x minus 5 plus 2x, and we were going to substitute x was equal to 7 into this, we would put the 7 in brackets. We do this every time. We put whatever we're substituting, we put it in brackets. When we're substituting, we're replacing something with something that has the same value. This is x being replaced with something the same value. This is 81 being replaced with the same thing, just written differently, 3 to the power of 4. Also, when we see the square root of 3, remember that we're going to replace that with 3 to the power of a half. So let's replace all the parts that we need to replace in this particular question and see what we get. 3 to the power of x minus 2 is equal to 3 to the power of 4 in brackets over 3 to the power of a half, and that whole thing was in brackets squared. We now start to use our rules in order to figure out what everything is. So we can see this whole thing here is in brackets. We have 3 to the power of 4 divided by 3 to the power of a half. So we know that's going to be 3 to the power of 4 minus a half. So this part here is this part here. And I write out everything the same as I go along each time. Okay, so if 3 to the power of x minus 2 equals 3 to the power of 4 minus a half squared, let's tidy that up. We like to tidy up as we go along. 3 to the power of x minus 2 is equal to 3 to the power of 3.5 squared. Also, I'm going to say I know this is true, therefore this is true. Therefore this is true. This is an equation, so I'll have my therefores in each line. then I have, therefore, 3 to the power of x minus 2 is equal to, so what's our rules for powers of indices? 3 to the power of 3.5 all to the power of 2 is 3 to the power of 7. We now have both sides written on the same base. So we have 3 to the power of something equals 3 to the power of something. So we know that whatever's in this box here must be the same as whatever's in this box over here. If you compare them, look, just compare them. The boxes must have the same value in them for this to work. So therefore, x minus 2 is equal to 7. Therefore, x is equal to 7 plus 2. Therefore, x is equal to 9. So the last thing that we do is we go and check our answer back in the original question. So this is quite easy with calculators now. We can just go 3 to the power of 7, type that into our calculator, or rather 3 to the power of 9 minus 2. Type that into our calculator and see what we get, and then type in 81 over the square root of 3 squared. Type that into our calculator and see what we get, and we'll get the answer that we are expecting. So that's the way we typically do indices questions. There's probably a few other ways that we can do it, but I think this is one of the best ways to do it. And that is write everything as a power of the same base as we go along. We replaced 81 with 3 to the power of 4 in brackets here. We replaced the square root of 3 as 3 to the power of a half in brackets here. And then we just used our rules and continued our way through. So let's go back to the original one. What sort of things do we replace? We replace 3. Any base, remember 1 can always be written as a base to the power of 0, so that might help. Also remember 1 over 3 is equal to 3 to the power of minus 1. Also 1 over 3 cubed is going to be equal to 3 to the power of minus 3. A few other ones we need to remember as well is the cubed root of something. For example, the cubed root of 9 can be written as 9 to the power of a third. So these are the two that will come across. The square root will be replaced with 3 to the power of a half. A cubed root will be replaced with a power of a third. Then you just follow through your rules and you continue like that. Let's look at one more question. So let's look at 2 to the power of 2x minus 1 is equal to 16 over the square root of 8 cubed. This is an exam question. Let's see what we get here. So same idea. We recognize that our base is 2, so we're going to be writing everything as powers of 2. So 16 is going to be replaced with 2 to the power of 4 in brackets. 8 is going to be replaced with 2 to the power of 3 in brackets. And then square roots, we'll deal with them in a minute. So 2 to the power of 2x minus 1 is equal to 2 to the power of 4 in brackets over the square root of 2 to the power of 3 in brackets, and this whole thing is to the power of 3. So we haven't dealt with everything we need to deal with just yet. We need to deal with the square root, and as we know, we replace the square root with a power of a half. Let's do that. 2 to the power of 2x minus 1 is equal to 2 to the power of 4 over 2 to the power of 3 in brackets to the power of a half. Now this whole thing is to the power of 3. So let's look at what we did here. We replaced 16 with 2 to the power of 4. We replaced 8 with 2 to the power of 3. And when we had replaced those, then we looked at the square root and replaced that with a power of a half. The reason we did this in 2 steps is we need to be careful. Some people end up replacing with 2 to the power of 3 and a half or something like that as well, or 2 to the power of 3.5, or they put the half in the wrong place. Replace the 8 with 2 to the power of 3 in brackets first, so it stays in brackets. This can stay in brackets as well. And then the square root is applied as a power of a half. Now we can use our rules and we see how they work out. So we have 2 to the power of 4 over 2 to the power of 3 all to the power of a half. we know from our rules that we just multiply them. Each step we write out the whole thing again. 2 to the power of 4 divided by 2 to the 3 over 2 is of course 2 to the power of 4 minus 3 over 2. And that whole thing is cubed. Therefore, 2 to the power of 2x minus 1 is equal to 2 to the power of 4 minus 3 over 2 is 2 to the power of 5 over 2. I'm sure you can add and subtract fractions at this point. All to the power of 3. Let's bring this up here to finish it. 2 to the power of 2x minus 1 is equal to 2 to the power of a power of something to the power of something again. You just multiply, so that's 2 to the power of 15 over 2. Okay, now look at the left hand side and look on the right hand side. This is the left hand side, this is the right hand side, and compare them. We know that they're equal, we know that they have the same value. If these have the same value, then these must be the same thing. So we get our equation 2 to the x minus 1 is equal to 15 over 2. What do we do with fractions? We always multiply across the entire equation by the lowest common denominator, which is 2 in this case. We do that so that we can cancel the fraction and we're left with 4x minus 2 is equal to 15. 4x is equal to 17. X is equal to 17 over 4. So there you go. There's two examples, and this is how we work with indices. Remember what the original thing is. We need to recognize powers of 3. When we see an 81, we know it's a power of 3 to the power of 4. When we see 16, we know it's 2 to the power of 4. When we see 8, we know it's 2 to the power of 3. Because we're using the base 2. In this one, we want a base of 3. Also remember, whenever we see a square root, we're going to be replacing that with a power of a half. And also replace your numbers with powers in brackets first, then do the square root parts, then do all your usage of powers. Okay, so there you go. There's your answer. You can check your answer at the end by putting the value of x back into the original equation and making sure that you get the same answer on both sides.